Welcome to Euclidean Geometry. Part 3. We continue with circle geometry, theorems and questions again. Listen very carefully. A very important theorem for the metric learners as well as the grade 11 learners. What is that? It is called Tan-chord theorem. The angle between a tangent and a chord. Look at this tangent, angle between the tangent ABC and the chord is BD. The theorem says the angle between this tangent and the chord, that is B2, is equal to angle in the alternate segment, that is E2. The same chord is making another angle at alternate segment. What is this alternate segment? Let me explain to you. Look at the chord BD. Okay, you can see one side of the chord. Look at this one. It's a small area. We can call it a segment, minor segment, because it is a smaller one compared to the other area. Okay, so this portion is called minor segment and the rest is called major segment. Okay, minor segment, and the other part of the other side of the chord, okay, is the whole thing is the major segment. Okay, this one is the major segment. So that is called also the alternate segment. So we divide the circular surface into two segments. Here is the one side of the chord and the other one, the other side of the chord. So the theorem says angle between tangent and chord will be equal to angle in the alternate segment. The same chord is making another angle here. Okay, so we start to prove that. Let us prove it now. Very easy steps. Given tangent ABC, required to prove angle CBD. This angle CBD is equal to angle BED. Look at that. That is what we are going to prove. What we do, we usually make some constructions. Draw a diameter BOF. Here is the diameter passing through the center and the point F there. Okay. Again, join EF. We join EF. That is our own construction. Okay. So we mark them with the dotted lines. You draw with the ruler and pencil or pen and then make it dotted lines. Now we are going to coming to the proof. Look at B1 plus B2. What is that? B1 plus B2 is 90 degrees. Okay, because the tangent is always perpendicular to the diameter. Again, look at E1 plus E2. That is also 90 degree because it is in the semicircle or it is subtended by the diameter. So we have two 90 degrees here. Now look at B1 and E1. How do we compare these two angles? There is some similarity. Look at the arc FD. The arc FD is subtending B1 here and E1 there. So they are equal because it is subtended by the same arc. FD subtends equal angles. Okay. Now what we find? What is the rest? 90 minus E1, 90 minus B1. They must be equal. Therefore we say B2 is equal to E2. B2 is equal to E2. That is our proof. So we conclude angle CBD is equal to angle BED. Okay, good. That is the proof. Good people, you practice 2 or 3 times and master it. It's a sure question. We are going to practice few questions on this theorem, application of this theorem, we call it riders. Calculate the value of the unknown angles. What are the unknown angles here? Look at the question. Unknown angles. Angle X, angle Y, and angle Z. We are given few angles here between the tangent and chord. Okay. So let us go to question number 1. That is angle X. How to calculate angle X? What is subtending this angle X? That is how we have to start. Which chord is making or subtending this angle? Where is the chord? The chord is BG. Look at that. Then we find a tangent at the point of contact. And the angle between tangent and chord, how much? 55 degrees. So according to the tan-chord theorem, angle X must be equal to angle between tangent and chord. What is that? 55 degrees. So we write X equal to 55 degrees. Reason, tan-chord theorem. Simple. Let's move on to Y. Concentrate on angle Y. Look at angle Y. Angle Y is here. Where is the chord? Which chord is subtending angle Y? Think. BE is the chord. Then we have the tangent. At the point of contact, we have an angle here between BE and the tangent. That is 50 degrees. So angle Y must be equal to 50 degrees. The same reason. Okay. Lastly, angle Z. Look at which chord is subtending angle Z. Find out. That is angle BF. Do we have an angle between that chord and the tangent? Yes. We have 75 degrees here. So angle Z is 75 degrees. Hope you understand the techniques. Okay. Very easy to score all these marks. A good question. ALB. ALB is a tangent. ALB parallel to MP. Prove that LM equal to LP. So LM and LP are the two sides of a triangle LMP. If we want to prove these two sides equal, then we'll concentrate on the base angles. If we can prove M1 equal to P1, okay. So let us look at the angles here. Angle L3, look at angle L3 is equal to P1. We apply tan-chord theorem there. Okay. Angle between tangent and chord is equal to L3 equal to P1. Also, we know that ALB is parallel to MP. It's already given. And therefore, L3, okay. Again, we come to L3 is equal to M1. Alternate angles. So, in conclusion, L3 is equal to P1, L3 equal to M1. So we can easily prove that. Therefore, L3 equal to M1, okay, P1 equal to M1. When P1 equal to M1, what is the meaning? The sides opposite to the angles, okay, are equal. Okay. So we conclude that. Let us go to the second question. LN bisects. That's what we have to prove. LN. Look at LN. LN bisects angle MNP. So what we have to prove here? N1 equal to N2. Okay. N1 equal to N2. Now, when we look at N1, N1 is subtended by LM. And N1 must be equal to angle L3, tan-chord theorem. Okay. N1 equal to L3, tan-chord theorem, and L3 is already equal to M1. Okay. Alternate angles. Now M1 and N2, is there any relation between M1 and N2? Look at the diagram. You see, M1 is subtended by the chord LP. The same chord LP is subtending another angle at N. That is the N2. Okay. So what we have noticed is M1 and N2 are equal because subtended by the same chord. So in conclusion, M1 equal to L3, M1 equal to N2, N1 is also equal to L3. So we have N1 equal to N2, N1 equal to N2. So what is the meaning? Therefore Ln bisects angle MNP. Now let us look at this beautiful question. Don't panic when you see a very complicated diagram. You just read, cool down and read. You will get all the answers. Here STU is a tangent, BC equal to CT, ATC equal to 105 degree, CTU 40 degree. And we have 3 questions here. So when you get the question, you read it 1 or 2 times and mark on the diagram. Okay, you mark the given information on the diagram sheet. So not on the diagram sheet, if you want you can use your question paper. So here is BC equal to CT. We mark that. So next time when we look at the question, we immediately click how to use that information. ATC is 105. This angle ATC is 105. Again CTU, we mark that. CTU is 40. Okay. Now we start. Calculate the size of angle A2. Where is A2? Look at this. A2 here. This is the angle we want. Now, which chord is subtending this angle? You concentrate on the chord. There it is. The chord is CT. CT is subtending A2. Now, we have a tangent at the point T with the chord CT. Chord CT and tangent at T. So we apply the tan-chord theorem here. We know that angle between tangent and chord, that is 40 degree, must be equal. It will be equal to the angle in the alternate segment. So we get A2 is equal to 40. Very quick. We get it faster. Now we write A2 equal to T3 equal to 40 degree. Reason? Tan-chord theorem. Question B, A1, go to A1. Here is angle A1. Which chord is subtending A1? That is chord BC. Look at chord BC. Now chord BC, we notice that chord BC is equal to chord CT. Okay, that is a great information for us. Look at that. They are equal. So the angles subtended by equal chords are equal. So this chord is subtending 40 degree. Now BC also must subtend 40 degree here. So angle A1 is 40 degree. Reason BC equal to CT. It's already given in the question. Lastly, we want B1 plus B2. Go to that angle. Here is B1 plus B2. It is an angle of the cyclic quadrilateral. We now make use of the cyclic quadrilateral theorems. We know that opposite angles of the cyclic quadrilaterals are supplementary. So look at the opposite angle. Here is opposite angle. How much is that? 105. So the angle B1 plus B2 is 180 minus 105. Okay, we get the angle, that is 75 degrees. Okay, good people, that's how we answer such questions. So that is the end of part 3 of Euclidean geometry. We have finished the theorems of circle geometry. Now we did few good questions. Practice as many questions as possible from the metric question papers. You get all the question papers and the memorandum from the internet. Practice them, master it, and score good marks. Good luck.